Okay, so I was debating how to make this video in the most efficient way possible for you to give you some direction about the linear programming project. It's not a difficult project, but the directions can be a little bit confusing in places, and I wanted to take some time to clarify what the directions were asking you to do. So here's the scenario, and it's actually pretty cool. So you are the new owner of a music shop in Greenwood. The previous owner fled the city to join the circus as a magician. Your first duty as new owner and store manager is to create an advertising plan based on the budget available. You must figure out how many magazine and TV ads to purchase. So what the situation is you've got this advertising budget. And you can put it in two places. You can put it in magazine ads or you can put it in TV ads. The TV ads cost $600 per airing, and the magazine ads cost $1,200 per issue. Now, keep in mind that the magazine ads are more expensive, but they have the potential to reach more people because it's per issue. So it goes out to everybody who is going to purchase a copy of the magazine, and they might see that ad multiple times. The TV ads are cheaper, but might not reach as many people. The total advertising budget is $9,000. So what we're trying to figure out is the best combination of TV ads and magazine ads to reach the most amount of people for the least amount of money. That is the goal. And so you've got these two different variables that are in play. So they are assigning the variables to you. X has to be the TV ads and Y has to be the magazine ads. And then it says write an inequality for our advertising budget. This inequality should have an X and a Y in it, and it would be less than or equal to $9,000. So you're dealing with the budget. So you're going to have something is less than or equal to the $9,000. And this expression over here needs to have X and Y in it. Okay, so that's what you're looking for. Then it's going to take you through a series of other inequalities that you need to write, but these ones should only have one variable in them. So like question 2 says, due to space limitations, the magazine publishers tell us that we are only allowed to purchase up to 6 magazine ads. Write an inequality for this constraint. And so what you're looking for there is like up to 6, you're going to have something with a 6, and then we're talking about magazine ads, and so this will only have a Y. Okay, so when you get to those ones, so the only inequality that has both the X and the Y in it, because you're dealing with both kinds of ads, is going to be the very first one. Right, well, let me go to the next slide. Maybe not. We'll do it that way. Okay. So question 4 is, it is impossible to buy a negative number of TV ads. Write an inequality for this constraint. So I want to clarify what is meant by this as well. The way they're approaching this is from a much simpler standpoint than what you are used to. So what you might do in writing inequalities for this situation is you might do something like this. -3 is less than or equal to X is less than or equal to 10. Okay, and you don't have any problem writing it as a compound inequality. This first page is actually taking you through it by making you do separate inequalities. So you might have something like X is less than or equal to 10, and then you'll have another inequality that says X is greater than or equal to -3. This question is the other side of the inequality. So you've got one inequality that's coming from the limitations that the TV show and the magazine publishers put on you. And then you have the other end of the inequality is coming from the fact that you can't buy a negative number of TV ads. So the fewest that, like the smallest number you could have there is a 0. All right, let's see if I can Ah, there we go. Now, on the next page, you need to graph all of them. And I'm not going to tell you how to graph it. You're going to end up with a bunch of inequalities and you're going to graph them all. And you want to keep in mind the area that you're shading. For this, I just want to give you an idea of what your final region should look like without telling you what the final region is, because why would I do that? So you would have something like this. You're going to have like these inequalities, and maybe this one you shade like above. And then you'll have another inequality that does something like this, and this one you shade below. And then there's another inequality bounding it. And so you're going to end up with these equations, and they're going to outline a region. Now that region represents all of the possible combinations of magazine and TV ads that you could have given the constraints that you have on you. What you're interested in are these vertex points. Okay, and you can tell from looking at your packet, you're going to have 5 of them. So clearly you're not going to have a triangle. But that's what you're aiming for on this. And what I would strongly suggest that you do is do this lightly in pencil, compare your graph to somebody else's, and just make sure that they agree and you're getting the same numbers. And if you're not, kind of talk it out, hash it out, figure out which one of you is right, wrong. Maybe you're both wrong. I don't know. And then if you need to, erase what you've done and redo it. Or if you've really messed up the graph, you can get a piece of graph paper or a piece of notebook paper and just redo it where it's cleaner and neater. But that's what you're aiming for there. The rest of the packet is usually pretty self-explanatory. I am going to say this, when you get to this part here, follow the directions because it says to plot the points. If you jump straight down to the questions after it, you will miss the points that are available for following the directions. Now, what this part is this is like media data that's collected that determine how the ads affect your sales. So somebody does a study and it says, okay, if you buy 5 TV ads, then you can expect to get $725 or increase in CD sales. Like that's your profit. If you buy 5, if you buy 6, it goes up to 900. If you don't buy any, obviously you don't get any increase from your ads. But you don't always get like the same results. So one person does a study and it says buying 3 ads led to 450, and somebody else does a study that says buying 3 ads leads to 600, which is how studies work. You don't get the same results. What you're looking for is that line of best fit. You're looking for the overall relationship. The more TV ads you buy, the more you'll get an increase in sales. And so you're looking to generalize it. So you should have a bunch of dots on this and then follow the questions at the bottom to get your line of best fit for it. When you get to the last page, this is when you want to put it all together, and students often have questions about what the directions mean on this particular part. So it says to write an objective function for the CD sales, okay? And here's what it looks like. So it's going to look like, and this notation like over here might throw you off a little bit, but it's going to be like f of x and y. So the function is a function that depends on both X and Y, both the TV and the magazine ads so that you're buying. And your function is going to look something like this, 2x plus 3y. Okay, it's going to look something like that, not with a 2 and a 3. But you'll use the numbers that you get from the previous 2 pages where you're doing the line of best fit. Those are going to give you the numbers that you want for that. And then your actual answer for this is going to look something like that. Then you're going to go back to that big graph that you did where you have the whole region that's shaded in, and you're going to pull those vertex points in, and you're going to plug the vertex points in. So if you had a vertex at say 1, 3, then you would plug it in like so. And then what do we have? 2 plus 9 is 11. And so the total sales would be 11. So whatever the X and the Y were, if you buy that many ads, then this is what you would get in sales. And then once you do that, you should be able to figure out the optimal number of TV and magazine ads. So I hope that this video helps clarify this as you're working on it. If you need to come back and watch this video and just kind of replay a part of it so that you know what kind of answer you should have. Hopefully, yeah, this will answer any questions that you might have.